senior data scientist at Banking Circle, and so this is the third example of Flower being used in production we've seen in this session. We saw blood counts, we saw Temenos, and now we're going to hear from Banking Circle. All of these three organizations are using Flower to do meaningful federations in production. So actually this is the second time that Robert's presented at Flower AI Summit, and so I can't wait to see how things are going at Banking Circle in the world of federated learning.
Thank you.
Over to you.
Hi. Thank you everyone for taking the time. My name's Rob. I'm going to take you through what we built at Banking Circle. I'll start with kind of a use case and why we think federated learning is a good fit, and then move on to what we've built and how it works. So it's a Federated Learning for Anti-money-laundering Enhancement System, or FLAME for short. I'll start with who we are as Banking Circle. So if you haven't heard of us, it's because we're a B2B bank, so all our clients, all our customers are other banks and other businesses, payment service providers and things like that. So we're an international bank. We process millions of payments every day, which is what's interesting for today's talk, because banks have to do AML. If you don't know what that is, just so we're all on the same page, AML is essentially what banks have to do to be sure that all the payments they see are not nefarious. So there's no money laundering, nothing illegal happening with those payments. Because we process millions a day, we have to check every single one of those and make sure that it's above board and nothing bad is happening. Clearly you can't do this manually, so what we do is try and employ machine learning to make this happen. So we have various stages to this process. It's a multi-model, multi-stage process, and when I say model, I mean machine learning models. But the one I'm going to focus on today, which is our main one, or one of our main ones, is a TensorFlow neural network. And all it tries to do, it's a binary classification system. It's trying to score payments with closer to 1 being more likely to be risk, bad payments, and closer to 0 being more likely to be no risk, so a clean payment. Features it takes as inputs is all the data we have about payments. So the value of the payment, who's sending it, who's receiving it, country it's going from, country it's going to. There's a lot more than just those. We have maybe 60 for every single payment, and a lot of those are kind of calculated fields and proprietary things we do. But to give you a flavor, it's information about payments in and a score between 0 and 1 out. And then the ones that are closer to 1, so the ones we think might be risky or potential money laundering, are sent to analysts to analyze manually, and the result of what they tell us is fed back in, so that's our ground truth. So why do we have a use case for federated learning? Well, we recently got a banking license in the US, which means we now have a sister bank in the US. And it's very difficult to move data across borders, particularly from Europe to the US. So we need fast and efficient and accurate anti-money laundering, as we have in Europe for our US sister bank. But because it's a new bank, it starts with no payments. So we don't have a body of data to learn from, and it's difficult, if not impossible, to share the body of data we do have. So here you naturally have a case for federated learning. There's someone we want to learn, and we don't want to share the data, or we can't share the data. So the solution is, can we train a federated model between the two continents, between Europe and the US? So we have two goals when we're looking at doing this. The first and foremost is to be performant in terms of our anti-money laundering machine learning model in the US. And secondary is, if we can get that working and that works well, is there anything from the US that Europe can learn anti-money laundering wise? And what we want to do is train a model in the US without enough data. And when I say enough, I mean not enough data to train a standalone machine learning model in the US. So even when we have very, very little payments data in the US, can we use federated learning to do something smarter than just dropping the European model into America? So I built Flame to kind of test this and see if it works, if we can get federated learning to do something here. For us, one bank is one supernode in terms of the framework, the latest Flower framework. The reason we do it that way is so we can have custom settings per bank. So the supernode level settings, which can differ across banks, which is a requirement depending on how you're storing data and what metrics you want out, things like that. For us, it's all containerized, so we use Docker, and it all runs in our Kubernetes cluster. And we're just finishing up switching from the old Flower framework to the new one. So we're on Flower 1.15 at the moment, and that really minimized the amount of orchestration we had to do. So before, under the old system, I had to spin up the server and the client separately, and there's a lot going on with YAML pipelines and webhooks and things like that. But with the long-lived Superlink and Supernodes, I don't have to handle this orchestration anymore. So the new setup adds, I would say, more layers, but it's a lot less for me to handle in terms of getting this thing to run. So a few features of Flame that we're quite proud of that are important for us is it's plug and play to add additional banks. So I'm talking today about our use case between the EU and the US, but there's other jurisdictions in the world we could add in the future, and there's also potential to add banks that are not affiliated with Banking Circle at all. So essentially marketplace rivals, because we're not sharing any private data, could participate in the system with us as well. As I've already mentioned, we've done quite a bit of work on custom client-side metrics and evaluation. So depending on what your data set looks like and exactly what your regulators want from you, you might be looking for different things in terms of what you consider to be a performance model. And that means you're looking at potentially different metrics. Choice of data sourcing sounds simple, but again, between different banks, different institutions, you might be sourcing data in very different ways. You need different options and literally different lines of code to make that happen. One cool thing I built in that I thought was quite fun was our experimentation mode. So because our use case is specifically seeing how the model changes as the volume of data ramps up on the US side, we built in an experimentation mode which runs experiments repeatedly, but adding a 10th more data on the US node each time. So we can simulate this with data and see what different volumes of data look like in terms of our federation, because we start off with this huge data imbalance. So in terms of testing it, in terms of experimentation, because we got the license recently, there's really not enough payment data on the US side to make it work. You can do federated learning with fairly low volumes of data, but no payments is not enough. So what I did was I took the data I do have, so European data, split it in two, and treated one half as if it's the US. So I don't have real live data, but I can test the theory. And then I tested, or the simplest test to do is against a baseline. So the baseline is a model trained on half of the data, and then the federated model is trained in a federated way on both sides. Results-wise, it looks like this. I don't go too much into the numbers here, but just to give you a flavor, generally we see some percentage increase across all of the major metrics you might be interested in when you're doing machine learning. The biggest one seems to be precision, generally speaking. These do vary a little bit depending on how I split the data, but generally this is what it looks like. So the answer is yes. In our case, federated learning works, and it seems to be a rather large improvement over not doing it in a federated way. So looking ahead, what we want to do in the future is, as I already touched upon, we have kind of two banks at the moment, Banking Circle EU, Banking Circle US. There's definitely room for more players, I think, and not just banks. It could be, there's other industries that also have to do AML. So PSPs, potentially, different kinds of banks, maybe even law firms sometimes find themselves to be quite heavily regulated. So we are interested to expand that, and that's something we're trying to do already in Luxembourg. So we're headquartered and therefore regulated in Luxembourg, and we're talking to some of the banks there to see if they might want to play with us as well. And the idea is there that the same theory holds. If you benefit from more data between two banks, you benefit even more from adding another two. So that was a very quick whistle-stop tour of Flame and what we're doing. If any of that sounds interesting, or you're interested in the kind of wider collaboration we're doing with federated learning in finance, then please feel free to drop me an email, and I'll be happy to have a chat with you about it. Thank you.
We have time for one quick question just from the front here. Mic is coming to you, so very good.
Hi, thank you for your presentation and interesting task. I'm wondering, as you have, let's say, your European model, which is quite performing well and mature, if I understood well, and you have the US model that is less performing because of the data. Have you considered knowledge distillation instead of a federated learning approach?
Sorry, could you repeat the...
Yes, have you considered knowledge distillation rather than a federated learning approach, as you have the US model that is quite immature and let's say the European model more mature?
The short answer is no. So because the US entity is fairly new, the first thing we tried was federated learning, and we got good results with that. But that's not to say there aren't other approaches that might also benefit.
Okay.
Yeah.
Thank you.
Well, thank you again, Rob. Thank you.
Thank you.